Uh, let's start with the today lecture. In this lecture, we will discuss the atomic masses and the molecular masses, how to calculate the atomic mass and the molecular mass and the average atomic mass. So first I will discuss, and later on we will do some sort of the very simple calculations. So here, one of the example is written over here. First, just I am going through the previous lecture in which we have already defined some subatomic particles, and the names for the subatomic particles are: number one is proton, neutron, and electrons. So these are the subatomic particles of any atom. So here we are, and then we also discuss the atomic number and the atomic mass. Let's suppose this is the element or the carbon atom. So what is the atomic number written over here? 6 is the atomic number. And what is the mass number? 12. So all information will be given. So you do not need to memorize all these things. Maybe I will give you the symbol of an element. And of course, I will give you the atomic number and the mass number. So important is how you are using these information to calculate rest of the information. Like with the atomic number, if I want to calculate the number of protons, how many number of protons are there in carbon 612? 6. So we represent, if we call this atom, so I have explained, or here this is called the carbon 612. 6 is the atomic number, 12 is the mass number. So atomic number must be less than the mass number. So you must always remember, maybe there are different representation of the elements. Somewhere the scientists use atomic number on the upper side and mass number on the lower side. But this is very simple to understand which one is the atomic number and which one is the atomic mass. So which is in less quantity or the less number, it must always be atomic number, and in higher value it must be a atomic mass. So by using the atomic number, you can calculate the number of the protons, and as you have said, there are the 6 number of protons. How many number of the neutrons? 6. How can you calculate? 12 minus 6, it will be 6 number of neutrons. And how many there are electrons? 6. Why there are 6 electrons? And because the number of protons are always equal to the number of the electrons, so the atomic number or the number of protons or the electrons, there should be a one number for each of the subatomic particles. Clear? अब इस information को हम जो है आगे वो use कर रहे नहीं है, तो you must always prepare before the class, and then you will pick up the idea what we are going to discuss in the next classes. Now I'm starting with the atomic mass. So as the atom is the smallest particle, so it is and its weight in gram is very much less to be measured by a simple equipment. Like one example is written over here. It is the dust particle. Dust particle are having the around exponent 16 atoms. That means 1 and 16 0. You can imagine how many atoms are there even in a one dust particle. So what would be the mass of? It is difficult to measure in gram. So we are using here another unit. This is called the atomic mass unit. So its value is 1 atomic mass unit is equal to 1.660539 exponent minus 24 grams. So it is difficult to measure this too much less gram, and that's why we are going to use another term which is called the atomic mass unit, or simply we will say AMU. AMU is the abbreviation of the atomic mass unit. So another reason is, like, it is simple Similar to the, like you use the term dozen. So dozen is 12 of anything. ठीक है, आप उसमें जो eggs, अगर 1 dozen eggs लेते हैं, that will be equal to 12. And if you buy or purchase 1 dozen mangoes or 1 dozen oranges, the value would also be 12. So dozen is representing the number is 12. Similarly, 1 AMU is representing the value of 1.66 exponent minus 24 gram. So this is the unit we will be using. This one, you must remember this unit because I will not going to give you this number. So you must remember 1 AMU will be equal to 1.660539 exponent minus 24. Even you remember 1.6 is, that is sufficient. There is no need to have, because exponent minus 24, if there is no need to actually to memorize all the rest of the figures. So how can I calculate this one? An example is written over here, like mass of 1 carbon 612 is, and this is the atomic mass unit, and you can easily find what is written at the element. जहाँ पे भी है वहाँ पे आप easily which one is the high number, that will be the atomic mass unit, and this is the AMU. And this, if you want to get the value of the 1 AMU, that means 1 AMU is equal to, you have to divide here, it is going to multiply with the m, and if you divide this one, so this will be the mass of one atom divided by 12. This is similar to this figure, and the value is 1.660 exponent minus 24. So actually important here is to remember that 1 AMU will be equal to this gram. So this is the unit conversion. So you must remember, and then we will be using this to calculate the from EMU to the atoms or the masses or the molecular masses of the molecule. So here, let's suppose if you want to pick any of the element, like in exam, I will give, let's suppose this is the oxygen, and this is written over here, this is the 8, and this is opposite to what I have mentioned before. So 8, and let's suppose this is the 16, 15.999, that means it is equal to the 16, around 16. So what is the atomic number over here in oxygen atom? Atomic number is 8, and mass number is 16, or the mass in AMU is 16 AMU. So this all information is given in the periodic table, and all this, the basic information will be given to you in the examination as well. Okay? Let's suppose there is another example. This is the calcium, and this is written over here 20, and let's suppose this is a 40. Atomic number is 20, and atomic weight or the mass number is the 40. So similarly, you can get all these information. So the mass in AMU will be 40 AMU. So actually the mass number is, actually we are calling it the AMU, atomic mass unit. Now, what are the isotopes? These two are the definitions, because I am using this information to further calculate the average atomic masses actually, and it is necessary to understand what are the isotopes. So isotopes are the element or the atom having the same number of protons, and but different atomic mass. So same proton means same atomic number. If they have the same atomic number but different mass, all these elements are the isotopes to each other, are we call the, let's suppose the example is written over here. This is the isotope of the hydrogen. So when it is one atomic number, it must always be the hydrogen. If you say the hydrogen, what is the atomic number of the hydrogen? It will always be a must. That I have already clearly mentioned, because these are, you say, these are the universal truths. When it is the one, it must be a hydrogen. And when it is hydrogen, the atomic number would be a 1. So what are the isotopes? How can they difference between these three different isotopes? And if you have a look over here, the first one is this hydrogen. This is the first one which is present in the periodic table. This is the atomic number, this is the mass number, and here 1, 2. Which one is the atomic number? 1 is the atomic number, 2 is the mass number. As I have said, if there is the two values, atomic number must be less than as compared to the atomic mass, because atomic mass is the sum of the protons and the neutrons, and in atomic number there are only number of the protons. So value must always be more in case of the mass number as compared to the atomic number. And in this case, again, atomic number 1, mass number 1. So if you want to calculate the number of protons in all these 3 hydrogen atoms are the same. So because all of them are having a 1 proton, that's why these are the isotopes, same number of protons. That means atomic number in these 3 hydrogen is same, and which is 1. Okay, and now you want to calculate the number of neutrons, and number of neutron, if 1 minus 1 will be equal to 0, so the first one does not has the number of neutron. There is only hydrogen atom, the first atomic number, it doesn't have the number of the neutron, only 1 proton and 1 electron. There are no number of the neutron. And if you want to calculate the number of neutrons for the second one, 2 minus 1 is 1, and for the third one, 3 minus 1 will be 2. So here again, there is the same atomic number, 1, 1, 1, but it is different mass number. First is 1, second is 2, third one is the third. So all these are the isotopes of the hydrogen. So isotopes are the atoms or the elements which are having the same atomic number but different mass number, or you can say same number of proton. That is the same thing, same atomic number or same number of the protons. It is the same word you can express the isotopes. Clear? Now we are using these isotopes to calculate the average atomic mass. So what would be the average atomic mass? As I have defined over here, average atomic mass is the weight average of all the isotopic masses. जितने भी आपके पास isotopes हैं, उन सब का average हम लेंगे. That would be the average atomic masses. So how can you calculate? Like this is the isotopes for the carbon, and actually these are all the naturally occurring isotopes. कुछ synthetic भी होते हैं जो scientists nuclear purpose के लिए हम उसको बनाते भी हैं, ठीक है? But here we are discussing the average atomic masses by using all the isotopes which are naturally present, not the synthetic. ठीक है? तो naturally जो present यहाँ पे है के यहाँ पे देखें दो isotopes यहाँ पे mention है. One is carbon 612, another one is the carbon 613. सही, same. And when it is a 6, it will remain carbon. When it is carbon, the atomic number must always be 6. So what is the difference over here? Mass number is the difference. That's why these are called the isotopes of the carbon. Carbon इसमें कोई और नहीं आएगा, सिर्फ carbon क्यों? Carbon है, hydrogen and other things are there. So second important thing is over here. It is what is the natural abundance? How much if it is a carbon? There are two isotopes. 98.89% is carbon 612 जो हमारे atmosphere में है, ठीक है? And only 1.11% is carbon 613, ठीक है? Or then we are going to use these information to calculate the average atomic mass, because average atomic mass is the average of these two isotopic masses. Then how can we calculate? This is the atomic mass of the carbon. To calculate the atomic mass of the carbon, here the mass of carbon 612 and its abundance plus mass of carbon 613 multiplied by its natural abundance. Then I am going to sum up and having a value of the 12.011. So let's see again. The second row is the mass of carbon 612 is 12, okay, and its abundance is 98.89. You have to divide by 100. Percentage को आपने natural figure के अंदर लेके आएंगे. So percent is always in 100. यही जो अपने marks के लिए भी आप use करते हैं. So you have to divide by 100. So when I divide 98.89 divided by 100, so the value would be 0.9889 plus, so this 13.0034 AMU is the mass of the carbon 613, and its abundance is 1.11, and if you divide the 1.11 with 100, so value will be 0.011, and then just you have to multiply these two value, and then sum up. After the sum up, you will get the value of 12.011. So this is the actually the average atomic mass of the carbon. तो आप देखें यहाँ पे दोबारा periodic table के ऊपर जाएं, तो देखें यहाँ पे कार्बन के ऊपर जो है, what is the value is written over here, 12.011. So this is actually periodic table के अंदर जो values लिखी हैं वो average atomic masses है. So average atomic masses are the sum of the or the average of the all the masses of one particular isotopes of the elements. ठीक है, ये अब आपके इसके अंदर. Let's suppose this is the nitrogen. Now do the calculation, and this is the mass number for one nitrogen atomic, this is the mass number, and atomic number is 7 for the nitrogen, but there is no need to use the atomic number over here because all these are the isotope for the nitrogen. This is nitrogen 714 and below is the nitrogen 715. Okay? And the weight are given, their percent abundance is also given. Now calculate what is the average atomic mass of nitrogen. शाबाश, जल्दी से करें ताकि हम एक्सरसाइज करते जाएं और आगे बढ़ते. $14.007 आपके सामने लिखा हुआ है. किसका आया? यही 6 के बाद सही. ठीक है, 6 आ गया, then you can round to the 7. Otherwise 6, 7 जो भी आपके पास है, this is also correct. जिसका नहीं है ये इसको नोट करें ताकि और सिमिलर आपके पास इसी तरह सिंपल सी आपके पास है. फाइनल मिल डेटा आपके पास गिवन है, you have to and और ये कोई भी आप एक्सरसाइज कर सकते हैं, इंटरनेट से भी आपको मिल जाएंगे, एंड you can verify these average atomic masses which are given in the periodic table. अभी आपको दोबारा से इसको ये देखिए, नाइट्रोजन is here at atomic number 7, and what is the mass? Average atomic mass is 14.007. वही आएगा आपके पास. ठीक है, and this you can use as a reference. You can do any of the calculation by using the values of the isotopes which are available. You can Google by using any elements. So another example, these I have already mentioned the answer over here. The first example number 3 is for the chlorine, and again Cl, there are 2 masses are available, and let's see, this is the mass number and it should always be in the whole number, and this is the exact mass actually what we are going to use to calculate the average atomic mass. And this is there again the percent abundance. Similarly, you have to divide the percent abundance by 100 and then multiply with the exact masses and then sum of all the isotopes, and it will give you the value of, let's suppose for the chlorine it is 35.453. At least you have to mention 3 scientific figures after the points. ये सब में ये standard हम ले रहे हैं. Let's suppose in chlorine is here and the mass is written over here 35.453 similar. So this is the periodic table you can use to calculate and to compare your result with the rest of the masses. Now I'm going to use the first one exercise, when we use the 1 AMU will be equal to 1.66 exponent minus 24 gram. Now the data is given over here. Let's suppose if the mass of the carbon is 1.00 milligram, and that means 1.00 milligram, you have to convert first into gram. That's why we did the first calculation. If sequence आपका नहीं आएगा, then it will be difficult to proceed further with the lectures. So I'm going to divide with the 1000 because 1 gram equal to 1000 milligram. So by using unit cancellation method or the unity method, you can convert into this. So this will be 1.00 exponent. This is minus, okay, it is not clear over here. This is minus 3 gram. And now I'm going to calculate how many atoms are there. In a similar way, we did the calculation for the unit conversion of gram to kilogram, kilogram to milligram. In a similar way, you can use over here. So I'm using the unit cancellation method. This is 1.00 exponent minus 3 gram. And this factor you have to remember. This, again, I'm saying I will not give you this factor. You have to use this factor to calculate into the AMU or to the gram. So 1 AMU will be equal to 1.66 exponent minus 24 gram. And this gram is going to cancel out. So what is left? AMU is left. And then I'm again multiplying with this factor. One atom, the mass of one atom will be equal to 12.011. This we have recently calculated. सही, तो आपने दोबारा से ये फैक्टर आपने लगाया 9. AMU is cancel out, and what is left? Only atoms are left. So you have to multiply this divided by this divided by this. The value will be 1.01 exponent 19 carbon atoms. So this is the way to calculate the atom present in the gram. That's why if you weight 1 milligram of carbon, this is the carbon. If the weight is 1 milligram, that means exponent minus 3 gram. So how many atoms are there? There are 5.01 exponent 19 carbon atoms in 1 milligram of the carbon. So this is the conversion to convert the weight into number of atoms. Very simple calculation. You have to use two unit conversion. The first one is this will remain constant. This is not going to vary from element to the element or from atom to atom, because this is the standard conversion. 1 AMU will be equal to 1.66 exponent minus 24 gram. Only this is going to vary, and it depends on what the number of atoms for which elements you are going to calculate. And if it is carbon, then the atomic mass unit of the one carbon atom is the 12. This is the same. This is the atomic mass or the average atomic mass we have calculated in the previous slide. So let's suppose if there is the oxygen atom, then how can you calculate the number of atoms? What should be the difference in this conversion factor? Just the last one conversion, you will replace one oxygen atom will be equal divided by 16 AMU, Shabash, because the atomic mass for the oxygen atom is the 16. So in this way you can calculate the mass. Let's work. This is another example. Calculate how many atoms are there in 36 gram of bromine. And bracket में आपके पास है the AMU of bromine is the 80. Atomic mass unit of bromine is 80. Now calculate the number of atoms present in 36 gram of the bromine. So ये फौरन आप अर्जेंट में होंगे. जी भजन जी हाँ बिल्कुल, ये आप एज एन रेफरेंस आप देखिए, ये वैल्यूज आप जो कांस्टेंट है वो आप नोट कर सकते हैं यहाँ पे। Have you calculated? Anyone of you have calculated? Exponent 22. Okay, let's see. Anyone else? $27. चलेंगे और बताएं शाबाश। कोई इशू है तो जरूर मेरे से शेयर करें कि आपसे कैलकुलेट नहीं हो रहा है, कैलकुलेटर यूज करना नहीं आ रहा है, जैसे मैटर। चलिए आप बताओ बच्चे, क्या निकाला आपने? क्यों क्या हो जाए? ये वैल्यूज आपके पास आती है, वे ऑफ कैलकुलेशन इज रिटर्न वैल्यू। चलिए कैलकुलेशन नहीं आ रही मुझे, और बताएं। अच्छा सिंपल क्या है, आप ये एक्सपोनेंट को छोड़ दें, सही, जस्ट लीव इट। क्या है, एक्स में -24, एक्चुअली ये आपसे हैंडल नहीं होगा, यही इशू है ना। तो व्हेन इट मूव टू द अपर साइड इट विल बिकम एक्सपोनेंट +24, जस्ट ये माइनस और प्लस आपके पास रहेगा, ठीक है। ऊपर आपके पास जो है वो एक्स में -3 है, ठीक है, ये आप वैसे भी यूज कर सकते हैं 0.001, या इसको भी आपको करना है एक्सपोनेंट -4, ऊपर जाके क्या हो जाएगा एक्सपोनेंट +24, +24 -3, what is the value? +21. Exponent 21 is the final which you have to use along with the other calculation. बाकी क्या बचा? 1 divided by, first you have to multiply 1.66 multiply by 12.01, then divide this figure by 1. ठीक है, 1 से इसको जो है वो डिवाइड कर दें तो आपके पास ये वैल्यूज आ जाएगी. क्लियर है ये? चलें आप करके बताएं, जल्दी से करें ताकि अगर नहीं है तो ये आपके पास है. द राइट आंसर इज 2.7 exponent 23 or 27 exponent 22. That is the same thing. But it's better when you use exponent, then we always use the point after the first figure. Okay? 2 के बाद भी point को use करना. So this is the standard notation. This is the way to how can you calculate. तो आपने जो है इसी तरह आपने एक्सपोनेंट जहाँ पे आ रहे हैं उसको आप कैलकुलेटर के अंदर कैलकुलेट ही ना करें. सही है, उसका सिर्फ साइन रिवर्स हो जाएगा. अगर नीचे माइनस है ऊपर वाला तो चेंज नहीं होगा क्योंकि आपके पास ऊपर वाला वही रहेगा, सिर्फ आपके पास जो डिवाइड है वो साइन जो है वो रिवर्स हो जाएगा. अगर माइनस है तो प्लस हो जाएगा, प्लस है तो माइनस हो जाएगा. ठीक है, बाकी आप माइनस की वैल्यूज हैं उसको कैलकुलेट करेंगे, यही आएगा. चलें एक दफा आप कैलकुलेटर यूज करें, देखिए अब आपके पास ये वैल्यूज आ रही है नहीं आ रही. तो आपके पास 36 डिवाइडेड बाय 1.6605 डिवाइडेड बाय 80 and the value would be 27. ठीक है, ऐसे ही. आ गया आंसर? अब किसी का नहीं आया? चलें फॉलो करें. वेट इज 36 डिवाइडेड बाय 1.6605 फिर डिवाइडेड बाय 80 and what is the answer? 0.27 और 2.7 एक्सपोनेंट -2. ठीक है, तो ऊपर आपके पास रेस्ट क्या, आपके पास आंसर क्या आया था? पावर 8 से. नहीं बच्चे यही है, 36 ग्राम आपके पास है. एंड द सेकंड इज यू हैव टू फर्स्ट टू कैलकुलेट द AMU. यू आर डिवाइडिंग 1 divided by 1.6605 exponent -24. This I have said, this factor will remain constant for all type of the calculation. This is not going to change. Like you use the dozen, I have given you the example. एक दर्जन अंडे लें या एक दर्जन आप ऑरेंज लें, वो 12 ही देगा, ना 13 देगा ना 11 देगा. ठीक है, तो 12 किसको रिप्रेजेंट कर रहा है? डजन को रिप्रेजेंट कर रहा है. इसी तरह AMU किसको रिप्रेजेंट कर रहा है? इस वैल्यू को रिप्रेजेंट कर रहा है. This value you will use to convert gram into AMU, and then you will put the atomic mass unit of any of the element which is given. तो आपके पास सिर्फ डिफरेंस जो है आपके पास यहाँ पे है, सिर्फ ये चेंज होगा डिपेंडिंग ऑन the atomic number, atomic weight of the element which is given. In case of the bromine it is 80, in case of the carbon it is 12.011. In case of the oxygen, it would be 16. So, ये भी information, atomic number, mass number, it will be given. But the simple calculation, you must know how to convert one unit to another unit, and which one is the actually the conversion factor. And the important is to remember 1 AMU will be equal to 1.66 0 exponent minus 24 gram. This you have to remember. Clear? (23) कैसे है? -24 को आप ऊपर लेके जाएंगे क्या होगा? +24 +24 अभी आपने कहा उसमें एक्सपोनेंट कितना है बच्चे? 0.27 जो है, तो 2.7 एक्सपोनेंट कितना हो गया? माइनस जो है वो आपके पास क्या आ गया? सॉरी, हाँ माइनस, हाँ 2.0 जो है वो एक्सपोनेंट माइनस आपके पास, इसको यहाँ पे कर लो कुछ और। लेट्स सी ओवर हियर, ये आपके पास आई डोंट नो 1.180 कितना ग्राम है? 36 ग्राम। Conversion 1 AMU will be equal to 1.6605 exponent minus 24. This is gram. Gram is cancelled. Then 1 AMU will be equal to 80. 1 bromine atom equal to 80 AMU, and this AMU cancel. आपसे ये करें आप, ये आपके पास फिगर है, ये आपके पास फिगर है, ये आपके पास फिगर है, इसको जो है वो आप अभी कैलकुलेशन में ना लाएं, ठीक है? ये क्या है, जो भी इसको सॉल्व करा, मैं इसको सॉल्व करूँ 36, ये नीचे क्या 1.6605 multiply by 80 and this will be exponent 20. सही, ये माइनस से जब अपर साइड में जाएगा तो वो प्लस हो जाएगा, अगर प्लस है तो माइनस हो जाएगा, इसका सिर्फ साइन क्या हो चेंज, ठीक है? अब आप बताएं ये वैल्यूज क्या है? 24 ये वैल्यू 0.27, ठीक है? अब ये भी सही है, इसको इस तरह लिखना है, रहने देने, कोई इसमें कोई गलत नहीं है, ठीक है? बट इट्स अ गुड थिंग टू कन्वर्ट इनटू द आफ्टर डिजिट वी यूज लाइक दिस, एक फिगर के बाद जो इसको, तो आपने इस तरह मूव करेंगे 2.71, तो ये एक्सपोनेंट -1, एक जितना मूव करेंगे उतना राइट की तरफ मूव करेंगे तो माइनस, लेफ्ट की तरफ मूव करेंगे तो प्लस, ठीक है? एंड this is exponent 24 is already given, plus 24 minus 1 23, so 2.71 exponent 23. Clear? So this is the way you can calculate to convert one unit to another unit. एक्चुअली सब कुछ पावर पॉइंट पेपर हो तो क्या ही बात है, सारे अंडरस्टैंड करना, तो मजबूरी है यहाँ पे जो है वो इसको बार बार जो है यहाँ पे ऐसा एक्सप्लेन नहीं कर सकते. सो आई एम जस्ट गोइंग टू फिनिश विद द टू एक्सप्लेन आफ्टर द मॉलिक्यूल्स, just 5 minutes more. So molecules, we have already defined the molecules. What is the definition of the molecules? One or more elements of the atoms which are together, these are called the molecule or the compound. That is the same thing. सही है? Compound, आपके पास compound are also the molecules, because in compound there are more than one element. In molecule there must also be more than one element. अगर एक से ज्यादा होंगे, दो या उससे ज्यादा होंगे, these are called the molecule. Like example written over here, this is the one molecule. The name of this molecule is called the ethylene, and its formula is this: carbon 2, hydrogen 4. And there are two elements, but in two elements there are 2 carbon and 4 hydrogen. Plus this is also a molecule, and this molecule is having the composition of hydrogen and the chlorine. This is the hydrochloric acid. सही, आप एसिड जो है वो यूज करते हैं, and this is going to produce another molecule this is the ethylene chloride, and this is C2H5Cl. So it depends. See, अब आपके पास क्या ये इसके अंदर जो है ये मर्ज हो गया, पहले H4 था, अब आपके पास H5 है, ये आपके पास C2 है, इधर भी C2 है, and Cl is going to be added up over here, and this is the ethylene chloride. But there is no need to remember this reaction. We are not going to discuss these reaction, but remember is actually what are these? These are the three different molecules because they are having more than one atom or the one elements are present in their structure formula. Clear? Then how can you calculate? This is the how can you calculate the molecular mass? बिल्कुल वैसे जैसे हमने atomic mass अभी calculate किया. तो इसमें क्या करें? These are the sum of the all masses of the atom. This will be the molecular mass. Like example, there are many example. जो अभी reaction है उसी की बात कर रहे हैं, ठीक है? Let's suppose this is the first molecule. आप देखें, गौर से देखें, कुछ भी नहीं है इसके अंदर, जो very simple calculation जो है. If I give you the molecule, of course I will give you the molecule with the composition, how many elements or the atoms are there. So this molecule is the ethylene having 2 carbon and 4 hydrogen. Now I am going to calculate the molecular mass of this molecule. अगर कार्बन का लेते हैं तो कार्बन का आपके पास क्या है? 1 कार्बन एटम इज दी 12 या 12.01. ये यहाँ पे आपके पास गुंजाइश है, आप एवरेज भी ले सकते हैं और जो है एटॉमिक नंबर, एटॉमिक मैस नंबर है, उसको भी आप जो है वो यूज कर सकते हैं, ठीक है? बट बेटर टू यूज व्हाट इंफॉर्मेशन इज गिवन. आपने वही यूज करनी जो मैं आपको दूंगा, उसको आपने यूज करते हुए इसको कैलकुलेट करने से रेस्ट ऑल इंफॉर्मेशन विल बी गिवन. सो द मास ऑफ 1 कार्बन एटम इज 12.0 AMU and how many atoms are there? 2 carbon atoms. So I am going to just multiply by 2 and the mass of the 2 carbon is 24. Similarly, mass of 1 hydrogen is 1. This is the you can get from the periodic table, and as we have also discussed in this class, the first hydrogen is the atomic number 1, mass number 1, and there are how many hydrogens are there? There are 4 hydrogens, so you have to multiply 4 by 1. The value will be 4.0, and then you have to sum up these two values, and this 24 plus 4, it will be 28.0 AMU. So this is the molecular mass of the ethylene. Clear? Now, if you want to calculate, similarly, calculate the ethyl chloride. Again, there are 2 carbon, 5 hydrogen, and 1 chlorine. There are 3 elements are present. So mass of 1 carbon is again 12. There are 2 carbon. Total mass of the carbon is 24. And similarly, there are 5 hydrogen and 1 hydrogen atom is having a mass of 1 AMU. So total will be 5.0 AMU. Mass of 1 chloride, there is no need to show over here because this only 1 atom is present and 1 atom is having the mass of 35.5, and you have to sum up. The total value will be 64.5, and this is the molecular mass of the ethyl chloride. Clear? So in this way you can calculate the mass of the any molecules by using their atomic atomic masses of individual elements, and the atomic masses of the individual element will be given to you. There is no need to memorize all these values. See, but only to memorize actually what is the formula, and this is also very clear over here how many atoms of carbon and the hydrogen or the chloride are there, and just you can use the given information. You have to multiply by first with the number of atoms and then sum of all the masses of the elements, which will give you the total molecular mass. Clear? This is all about today's lecture, and further we will explore further. There are, I think, 2 more conversions are left, and we will discuss in the next class. बच्चे बैठे हैं अभी बैठे